Cheers guys, I hope you're good. This is Patrick Egan. The channel is Patrick Egan. Today I want us to look at what is called an MCC, that is a motor control center. This is a type of electrical panel. I want us to study what are the components inside it, their electrical wiring, their functionalities, and how they are intertwined to function in different applications. Welcome. And in case you have not subscribed to the channel, please subscribe to support us for this content. Inside the panel, then I'll later show you what is happening outside that particular part. So let us go down here and look at our main power supply. This is the main isolator. As you can see, it has a three-phase power supply, that is a RYB. So we have, this is a 415 system. Then it's also good to note that we have an earthing supply, then we have a neutral block. Then also important to note is that in our cable, in our panel, we have done earthing. This one is to protect in case of any leakages, and thus protecting human life against any electrical shock. So at top here, you're going to see the first line. In the first line, we have what is called an RCBO. Then this RCBO will supply the power directly first to the control phase controller. That one is important to ensure that the voltages, all the three voltages are supplied to your motors, because in case the phase controller doesn't work, it means your motors will be supplied by maybe one or two phases, thus introducing the challenge of single phasing. So in our wiring, this is our priority number one. In case the phase controller fails, all these mechanisms will cancel out, so that you are going to protect your motors. So the function of the RCBO, apart from acting as an RCD, it has an extension protection against earth leakages. So this one protects the human life from exposure to earth leakage, or in case you have injury in your wiring line, you can be able to sense. In case you have any weird earth leakage of your current, this one will be able to function. So maybe I give you a test. You can see when you want to test this RCD function, that one works. So as an engineer or as an electrical personnel, it is good to ensure that your RCDs are working. So in our case here, we normally do biannual or sometimes a annual checkup of RCDs, that is after commissioning. Before commissioning, it's good you also study this and do all the tests to ensure that you have a safe MCC. So alongside the RCBO, we have the conventional RCDs. Then from the RCDs, we graduate to MCBs. So that is basically what we are seeing in this line. This is just RCB connected with an RCD, supplying different lines of our loads. Something else special from there, apart from the RCBs, we come to this line. So from here, this is a different functionality. You can see this is an overload protection system. Overload protection system, which are interconnected with your contactors. So the contactors are labeled accordingly depending on the loads you are going to supply. It's also important to note that somewhere here we have a timer, and also here we have a timer. So this timer is controlling how the board. Inside the board we have a fan which regulates the amount of the environmental condition of the MCC. So that is regulated by that timer. Then you have this timer which sets on other parameters controlling our loads. So depending on your application, you may have numerous timers inside your MCC, but in our case we only have two. So let us go back to the overload protection scheme. As you can see, we have a yellow part in our MCC, then in our overload protection scheme. This one gives us the allowance to set the current capability of our motors, what we want the motors to operate from. So you have a different ranges depending on the size of the motor you're going to control. In our case, we have applications ranging from 2.5 amperes per phase to 6.3 amperes per phase. This is because we have different kinds of motors in the house. So the power, when it has flown all the way from the RCBO, the main RCBO through the phase controller, it now goes to the contactors, through the protection scheme, that is the overload contactors. We have this terminal block. So this terminal block is an integration. We have a single phase terminal blocks and we have 3-phase terminal blocks depending on the loads we have down there. So in this case, the wiring scheme is 1, 2, 3. You are going to choose how you are going to wire your particular motors depending on the direction you want the motors to go to, and depending on your other applications. But it is important to note that whenever you choose an RYB sequence on the supply end, ensure that you are using the same RYB sequence in the outgoing mode. That is depending on the direction of the motor you want it to go to. So let us come to this other side of the MCC. You can see we have two PCBs, that is printed circuit boards. I'll come back to this top one, but let us focus on this big one. This is the brain behind this particular MCC. As you can see, this one is interconnected using a flex tube, flex cable mounted in this particular screen. This is what's called the Viper touch. This provides the human interface you need to be able to control your MCC, the functionalities of the MCC. We are going to see what happens outside there, but you can see this is just a collection of circuit breakers and the circuitry, that is the ICs, and most importantly the relays, which switches on and off depending on what you need. So mentioning of relays, it's also good to show that we have also another line of relays down here. Depending on the application, you can have the different varieties of relays in your MCC. For us, this is the normal mechanical relays. We have the latching relays and the different types of relays depending on the switching parameters you want to inculcate in your system. It's also important to note that we have also this is a timer which goes along with this. This is a control for lighting system. So someone will be asking, how are you going to power your relay system? So we have a transformer here. From this transformer, you are going to supply yourself with 24 volts VAC, 24 volts VDC, 12 volts VDC, or whatever voltage you have, because it has different tappings, it has different outputs. So that is the function of this particular transformer. We don't supply the transformer with 415, we supply it with 230 volts at the other end. So let us go back to this PCB. This PCB is important because we have a motor which operates on variation mode. Variation mode means we control the speed of this particular motor depending on the amount of voltage we supply. So for us to be able to have this switching capability, we have a PCB which switches between the different voltage outputs so that it can be able to control our motor. So let's go back to how you are going to dress your particular MCC. You can see these are channels. These are important because you want one, your MCC should be neat, and then two, you don't want this one to be exposed to any Tom, Dick and Harry. You need someone who knows exactly what they are going to do, what they are doing in this particular panel to be able to access your cabling. So that is how you can see. If you are going to release all the cabling here, it could have been a mess. It could have been a dirty, very dirty job. So let us come back to this section of the MCC. This is the back end of this of the switches of the human control capability. This is where now the end user can be able to control on-off functions. These are just selector switches. Depending on what we need, we have switches we can do 3 selections or 2 selections. Before we go that, let us see what is this element here. This is just a normal battery, 12 VDC. This is supplying our alarm system. This is important in our application because it protects against any loss of power. In case we have a loss of power, this one acts as an emergency together with this circuitry to be able to do the other functions to make the house be able to function. It is important for you as an engineer or as an electrical personnel to ensure that your system has been wired such that in case of any functionality, in case of any fault, you have an alarm system which can be able to let you be able to control this particular fault. So let us go outside and see what happens on the other end. This is the outside section of our MCC. This is what is normally accessed by the end user. You don't need a lot of training to be able to control this. But starting from this, you can see this is a breathing mechanism for the MCC. We have one here and we have 2 there. Then I told you when we were doing the study there that we have a timer which controls how the fan which regulates the internal environment of this MCC operates. So this is just the alarm system. This is acts as a backup system in case there is a failure in our MCC. This is not a must for your application, but in our system, this is a backup which is controlled by thermostats, which enables us to control the house in case there is a power loss. So you can see here, this is the screen. This one is the human interface. You can be able to operate whatever you want to input. So you can be able to do as many functions as you want depending on what particular control you want. In our case, we have the climate, production, management, technical. You can be able to do calibration, setup, and all that functionalities. So this one gives you the ultimate control of what is happening inside the house. So this one are the switching mechanisms I was sharing with you. You can see this one is 3. You can have 3 selections. So you can have that is selection 1, 2, and 3. So in our MCC, you have the capacity to do an automatic control or a manual control. So if you want to do a manual control, what you normally do, for example, in this case, you do M. This one, as you can see, the lighting, it means that our motors are running in manual mode. But because you have a control circuitry, you have a control software, you have been able to input all the key parameters you want in the house, you leave this one operating on automatic mode. So we have 2 important pilot lights here. This one displays if you have a fault in your system. For example, let me simulate a fault. As you can see, this one shows that you have a failure, and you can see what is happening here. You can see line 1 is open. So this one means our motor, our alarm is working to indicate that you have a failure in one of your circuitry. On this other hand, you have the same. Then this one is a switch. You can do off, on, and then you can do top or down movement depending on what you want. So guys, maybe the last thing you are going to see here, this is a on-off, main on or off mechanism for this particular board. It's normally intertwined with the main supply so that you can be able to control your power flow. So that has been it. This is Patrick Egon. We give you content in engineering, we give you content in publishing, we give you content in inspiration and book publishing. It has been nice being with you. I hope you learned something. Until next time, stay well. Thank you so much.